Will, would you please read today's purpose?
I will see what determines the velocity of a wave.
Relevance, Maddie.
We'll be studying waves for several weeks.
Wade, success.
When I can say the relationship between velocity, amplitude, and medium.
Today's grades, I'm changing my notation here a little bit. I'm going to throw in some more letters in front, so we have L for labs, H for homeworks, and Q for quizzes, that kind of a thing. So you have a Schoology thing to type in, a little bit of a lab. Quiz, let's see, if today's day 101, that means that that's going to be Monday, unfortunately. Materials, a big slinky. Look at the back of the lab. We have big slinkies on pipes. The pipes are there so that the big slinkies don't get tangled. Unfortunately, somehow they still can get tangled. I have no idea what kind of magic hocus pocus is going on back there, but I have seen them somehow get tangled. So if it happens to you, don't really worry about it. I'm not going to scold you. I know it happens. But then again, don't go crazy on these things and shake them to such vigor that it might break. Anyway, somewhere in between. So that's the big slinky. Small slinky. Sometimes these are called snakies because they look like, well, they kind of feel like a snake. If you actually have held one of those critters, they have this tense feeling, and this is very similar to that. So this is a snaky or a small slinky. Stopwatch is in the front here along with the measuring tapes, just as they always have been, and ring stands are in the back as well. Okay, part 1, rules. Slinkies are fun to play with. But please remember these rules. Keep them on the floor or the tabletop. Do not shake up and down, bouncing on the floor, jump roping. Do not have two slinkies side by side. If they collide, they can get tangled. Do not stretch the slinky and then let go. They snap and get tangled up. Do not overstretch the slinkies. Now, with the new equipment here, it's only a couple years old. I've avoided some of those issues. I haven't changed the printouts accordingly, but that's all right. The idea is here, let's not go crazy on these things, but they're like lasers. You can't help but play with them, and that's okay. Part 2, learning vocabulary. Get a big slinky and lay it on the floor so it's not stretched much, but enough to keep it in a straight line. Hold each end down. One person moves their end to make a wave pulse in the following manner. Make a quick wave pulse by pushing and pulling on one end in the same direction as the slinky is lined up. Do this quickly. This is called a longitudinal wave. Okay, so here I have a big slinky that is not on a pipe, and I need your help on this, please, Davis. Okay, so if I was to move my hand this way, that's in the same direction as the length of the slinky, and that's going to make a little bit of a pulse that we can see. Let's put it on the floor so we can see it a little better. And you reach on down, and I'm going to go this way, and you can see the areas where the slinky coils are closer together. That is a longitudinal wave. Go ahead and put that down on the floor. So, let's see here. I believe it says we're going to draw a picture of this. So we're going to have places where the coils are far apart, and then when they're close together, and then they're far apart again, and then they're close together, far apart, close together. So this is areas where they are compressed, and these are areas right here and here where they are stretched out. These places where they are smooshed together, those are areas of compression. Those are also called crests. The distance between the crests is called the wavelength. So the wavelength is from there to there. Wavelength. The symbol for wavelength is this thing right there. We're going to call this the dinosaur symbol. Why would we call that the dinosaur symbol, you might ask? Well, it's because it looks like a dinosaur. Right, there's the dinosaur, there's the lambda symbol, there's a striking similarity between the two. Letter D. The distance particles move from their rest position is called the amplitude. As we lay the slinky down in a nice restful position, all of the coils are equally spaced apart. The coils then vibrate back and forth from that resting position. They vibrate one direction and they vibrate the other direction. The distance from the resting point is the amplitude. It is not the total distance that they travel from one side all the way to the other. It's from the middle resting position to one extreme. Make a wave pulse go down the slinky by shaking one end perpendicular to the slinky side by side on the floor. Okay, so, look at that. That's how quick they become tangled. Oh, that's awful. Okay, anyway, we're going to be shaking it up and down like this, and we can see that the wave pulse goes down in that way. Oh my word. Oh, this is awful. Ooh. Thomas, I'm going to have you take the slinky over to Mr. Lobenstein, and I'm going to blame you for having that tangled, okay? Sure. Thank you. Okay, so we're not going to be able to make wave pulses down here because it's already got tangled up. But we're going to make a picture of it. So we're going to have the coils, and then we're going to make a hump like this. And it's going to go up and down. The coils are all equally spaced apart. It's just that they are moving. Oh my goodness. Please try to draw that. I'm just making it worse. Label the wavelength on each side. Okay, so from one, we call this the crest again. In one place, in the previous wave, the crest was when they're closest together. They vibrated as far as they can in one direction, smooshing. Well, here they're vibrating again the most that they can, but instead of smooshing, they're stretching left and right. So that's a crest, and that's a crest. The distance between two crests, then, that is the wavelength. We could also say that it's from one bottom to the other bottom of the wave. These are called the troughs. The bottom of the wave is a trough. The distance between two troughs is the same wavelength. It doesn't matter if you measure the top crests or the bottom troughs, it's the same wavelength. The amplitude is the distance from the center point to one extreme. There's the amplitude, capital A. Or here, from the middle to the bottom, capital A. This solid line here is the resting position. So the distance from there up to the crest, or from the middle down to the trough, is the amplitude, capital A. Common mistake alert. People often mistake amplitude to be the distance from the very top to the very bottom. That's wrong. Don't think of that. In the second part of the lab, we will just measure transverse wave pulses. That's what this is, where it's moving perpendicular. Draw a picture of a single transverse wave pulse when it's halfway down the slinky. 1 pulse. Something along that lines. Most of the time, you will make wave pulses with a quick jerk of your hand. So, let's get one of those. Here, hold this again. You're going to be using wave pulses with this kind of a small slinky. It's snaky. Go ahead and put it on the floor. And you're just going to do a really fast little jerk like that. Okay. Just one at a time so you can watch it go down and do some stopwatching of that one hump. Thank you. Okay, so what does it say here? Letter G is how many waves are made per second. This is the frequency. We had frequency last semester when we talked about how many circles were made every second. And we labeled that in something called a hertz. In equations, this is shown by the variable little f. Remember that capital F is force. Oops, let's get that up on the screen. Letter I, the blank is how long it takes to make one full wave. That is the period. Equations, this is capital T. The relationship between frequency and period is the same as for circular motion. Frequency is 1 over the period. And if you want, you can flippity-floppity this. You could say that the period is 1 over the frequency. Either way works. All right, and that is the end of the little note introduction. We then have the Slinky Lab, 30 minutes, and then we're going to enter questions into Schoology, and that will be the end of that.